tuning in this afternoon. My name is Elizabeth Tammy. I was a Georgia Space Grant recipient in the summer of 2019, and I worked at NASA's Goddard Space Flight Center in Greenbelt, Maryland as an audio production and newsroom intern. I just graduated from Mercer University in Macon, Georgia with a degree in journalism and creative writing, which, yes, is not typically what we associate with NASA, but I will get into that a bit later. I was lucky enough to accept a full-time position back at NASA's Goddard Space Flight Center after graduation, albeit remotely for now because of COVID, as the outreach and social media lead for the Hubble Space Telescope mission. I'll talk more about my job later on in the presentation, and at the end I'll answer any questions, so feel free to put them in the chat. And now I might be biased, but I think that Hubble is a really cool mission with a super interesting story. So I would love to just give you all kind of the Spark Notes edition of that. So here we go. So I will be the first to admit that even though I feel like Hubble is a household name, at least it was one that I was familiar with, I actually didn't know that the Hubble Space Telescope was in space until I was about a teenager. And, you know, I think that Hubble being in space is really interesting, and it's all just being about above Earth's atmosphere. So the problem isn't distance, it's just getting above Earth's atmosphere. It's only 340 miles above the surface of the Earth. It's orbiting about every 95 minutes, 17,000 miles per hour. It's the size of a school bus. It has an 8-foot diameter mirror. It's really amazing technology. And like I said, it's not that far from us, but getting above the atmosphere is really critical in seeing into the universe, because even though we have really powerful telescopes down here on Earth, our atmosphere is actually really murky. It's like a soup. It basically absorbs a lot of wavelengths that are harmful to us humans, which is good, but it does impede our vision. We can't see crystal clear unless we're above Earth's atmosphere. So Hubble has this really amazing vision, and something that I think puts that into perspective is that Hubble could shine a laser beam onto the head of Roosevelt on a dime from 200 miles away. It's very precise and extremely clear, and it can see as far as 13.5 billion light years away, which is honestly just unfathomable to me. So let's go back a little bit. You know, telescopes obviously have been around for a while, and they've definitely helped us learn more about our place in the universe. You know, realizing that Earth isn't actually at the center of anything. You know, we orbit around the sun, and our solar system is just a tiny, tiny part of this huge galaxy, and later learning that we're just one galaxy among countless galaxies in our universe. So we've learned a lot, and we have really powerful ground-based telescopes, usually on top of mountains or hills in remote regions. And they've made some really important, incredible observations, of course, but there's still that atmosphere to deal with. So in the 1920s, a German scientist named Hermann Oberth put forth the idea of launching a telescope into space. He was one of the fathers of rocketry. And so he put forth that idea, and then Lyman Spitzer in the 1940s kind of, you know, wrote down the specifics of what that would look like. How do you put an orbiting observatory into space? How would that even work? And eventually NASA in 1969 approved what was then known as the Large Space Telescope Project. And so there was a working group in the 1970s focusing on, you know, what instruments are we going to have on board? How is this telescope going to work? What's it going to cost? All of that fun logistical stuff. And there were a fair amount of delays just because this was unprecedented technology. I mean, nothing like this had really been done before on this scale. So in terms of figuring out how this was going to work, what it was going to cost, it was a lot. And unfortunately, with the Challenger tragedy of 1986, that grounded the space shuttle program for a while. And Hubble and the space shuttle program really worked in tandem, because Hubble was always intended to be launched and deployed by the space shuttle, and later on serviced by astronauts using the space shuttle. So before Hubble launched, it got its name after Edwin Hubble, who is pictured here on the right. And he kind of suggested the idea that the universe is expanding. It's not a still thing. The galaxies are moving away from each other, and we're not sure why. So he was the first one to put forth that theory. and that has been one of Hubble's primary objectives throughout its whole life. So it's a very fitting name for this telescope. And finally, on April 24th, 1990, Hubble launched on the space shuttle and was deployed. And it was intended to last for about 15 years and be routinely serviced by astronauts using the shuttle. So let's take a look at the first image that Hubble sent down. And you can already see that there is a big difference in clarity between, one of the best ground-based observatories and Hubble. It's all about that atmosphere. So unfortunately, all was not well with Hubble. So about a few months into Hubble's deployment, it became clear that there was a pretty big issue. The mirror was just ground slightly incorrectly, literally to less than the width of a human hair, which seems like nothing, but when you're talking about technology at this level, it just, it was a big deal. It was a big public relations crisis. Hubble was made fun of on late night talk shows and all that fun stuff. Both the scientific community and the general public was feeling frustrated and confused. Several people on the Hubble project have commented that, there were a lot of, like with any space mission, things that could go wrong, anticipating what could go wrong. The mirror was never really on anyone's mind because it's such a, fundamental part of a telescope. So it was just kind of hard for everyone to wrap their heads around. But I should disclaim that it wasn't like this telescope was unusable with this aberration, because scientists could still use it. Hubble was still making observations. It just wasn't the crystal clear images that had been promised to both the scientific community and the general public. So fixing that spherical aberration became the primary objective of the first astronaut servicing mission. So in 1993, the first servicing mission launched, and they installed a corrective instrument called COSTAR, and that basically worked like a pair of glasses for Hubble. So rather than changing anything about the mirror itself, this was just correcting the way that the light hit the mirror so that Hubble could see clearly into the universe. And future instruments that were installed on Hubble, like cameras and other scientific instruments, were all made with that spherical aberration in mind so that it just preemptively corrected for that tiny error. Servicing Mission 1 was a huge success, and you can see how clearly Hubble was able to see afterwards. So there's the same image taken before and after that first servicing mission and the installation of COSTAR. So yeah, huge success. It started bringing in super amazing and iconic imagery, and it proved how critical those astronaut servicing missions would be to Hubble throughout its lifetime. There were 5 total servicing missions during the Space Shuttle program that allowed the Hubble Space Telescope to be repaired and upgraded. Truly, it is not the same telescope today that it was when it first launched in 1990, simply because technology has progressed so much in the last 30 years that we've been able to install these new, amazing, advanced instruments and cameras that have truly just, rejuvenated the telescope again and again. So here are just a couple examples of Hubble's amazing imagery. You've got the Mystic Mountain on the left and interacting galaxies on the right. I'm sure if you haven't seen these images before, you've seen images very similar to them. And that's just because Hubble has really transformed the way that we think about the universe, the way we imagine it, the way we talk about it. Its imagery has literally just changed everything about the way that we think about this stuff. So you see this imagery everywhere, in movies, on clothes, on school supplies. Something I remember when I started working for the Hubble mission and really, taking a deep dive into the history and the images, was looking at things and being like, oh, I recognize that, I know that. And it goes to show how prevalent that these images have become in society and culture throughout the world. The fact that I know these images, I've seen these images growing up in textbooks or on posters, it's amazing. It really has changed the whole world's perception of outer space, which I think is awesome. And another thing that I think Hubble is going to be specifically remembered for is its deep field imagery. Now, I'm sure you have seen this image or one very similar to it. Hubble's deep field images, I think, create a real sense of vertigo on the edge of an existential crisis, for sure. They're really, really incredible images, and the story behind them, I think, is really interesting. So the first deep field image was taken in the mid-1990s, and when the idea was put forth, people kind of were, tilting their heads at it in the scientific community, because the idea was basically to take a sample of the universe. So they were going to point Hubble at a seemingly empty patch of sky of the universe, just to see what could be seen, and also to get away from the brighter lights of the Milky Way and all that. But it got mixed reactions at first, from what I understand, because something you have to understand is that Hubble time is extremely valuable. Getting time with to observe with Hubble is cutthroat competition. Truly, astronomers from all over the world have to put in really detailed proposals, and it goes through an intense review process. So the idea that not only were we going to stare at a part of the sky where there wasn't necessarily anything we knew there, and also for a really long time, about 10 days, it was like, what? But Hubble did that. It took an extremely long exposure, gathering all the light that it could, and when the results came back, it changed everything, literally everything, because you have to think that every point of light that you see in this image, it's not a planet, it's not a star, it's an entire galaxy. And this is just one tiny sampling. And our own Milky Way galaxy is 100,000 light years across. So like, there's not even like a way to understand how we could even explore the edges of our own galaxy. And now we're finding out that there are thousands and thousands and thousands of other whole galaxies out there with untold things within them. It's really amazing. And I think it, proves the point that a lot of astronomers say, that in the field of astronomy, you can divide it into two parts, before Hubble and after Hubble. That is how drastically it changed everything that we know about our universe. Here is the cosmic Reef image, which is what we released as a celebration for Hubble's 30th anniversary this past April. It's a beautiful image, absolutely beautiful. And I love looking at it and remembering that this is the 30th anniversary year, because this means that Hubble has officially, lived twice its expected lifetime. That's awesome. And that's largely a result of the servicing missions. But another thing is to think about, me and a lot of other people, we have never known a time without Hubble. Hubble was in orbit for 8 years before I was even born. So to think that I have always lived in a world where Hubble has existed is pretty amazing. This is how I've always imagined the universe and thought about the universe and talked about it. And I think that it just has an incredible power to inspire and to interest people in the sciences and space exploration and learning about our place in the universe. Hubble has, studied everything from exoplanets to the birth and death of stars and galaxies and galactic evolution, gravitational lensing, so many things. It's really answered questions that we had never even thought to ask before Hubble launched. It's amazing, and I feel really grateful that I've always lived in a world with Hubble. And I am so excited that it's continuing to, create great science, amazing images, and it's expected to last well into this decade, which is super exciting. To date, Hubble has performed well over 1.5 million observations, and its data has been featured in over 17,000 scientific publications. And it's just getting started. So it's been a really successful mission, especially thinking about its very troubled beginnings and the decades of research and planning that went into Hubble before it even launched. It's been a really long road, and I think especially this year as we celebrate the 30th anniversary, it's amazing to reflect back and think about how much we've learned and how much we're going to continue to learn because of this telescope. It's been a really awesome journey for sure. So there are a couple more space telescopes coming up in the near future from NASA. So I wanted to talk just a bit about each of them. I'm really excited for both of these missions. Next Halloween, the James Webb Space Telescope is expected to launch. And the goal is that Hubble and James Webb will be able to work in tandem with each other for at least a few years. That's the goal. James Webb is going to be really amazing. It's going to find out more about the age of our universe, look farther back in space and time than Hubble can. It sees in infrared, and it's going to make some really important observations. And another cool thing is that it's actually going to be orbiting at Lagrange point 2, which is nearly 1 million miles away. So that'll certainly help. It's much farther than Hubble is at just 340 miles above Earth's surface. So it's going to be a really, really spectacular mission, and everyone at NASA is so excited to see what James Webb will see. And then a little later this decade, the Nancy Grace Roman Space Telescope is planned to launch. And this was formerly known as the W-FIRST telescope, the Wide Field Infrared Survey Telescope, but it was renamed after Nancy Grace Roman a few months ago, which the Hubble team is really excited about because Nancy Grace Roman is remembered fondly as the mother of Hubble. She was NASA's chief of astronomy during a lot of the planning for the Hubble mission, and without her expertise and her passion for the Hubble project, there is just simply no way that this mission would have happened. She really, really was a huge champion of the Hubble Space Telescope project, and it seems very fitting that she's going to get her own really powerful space telescope. The cool part about Roman is that it's going to be able to make survey observations, which is going to be really, really helpful and interesting because Hubble and Webb, we make targeted observations, but Roman is going to be able to see huge parts of the universe all at once, which I think is going to lead to some really, really fascinating discoveries. Webb and Roman are going to study a lot of things, including black holes, dark energy, and dark matter, which is kind of the invisible scaffolding of the universe, which we think is, responsible for the universe's accelerating expansion. So they've got a lot of really cool goals, and the Hubble team is really excited to see where they go with it. So I am going to pivot slightly back towards my Georgia Space Grant experience. Like I mentioned, I worked at Goddard Space Flight Center last summer as an audio production and newsroom intern. It was a ton of fun, and I knew within a few weeks of being there that I wanted to return full-time after graduation. It was just so much fun, and I got to help curate this oral history playlist that celebrated the 50th anniversary of the Apollo 11 mission, the moon landing. And that was incredibly exciting and rewarding. And on top of that, I just got to try all different aspects of media at NASA. So I got to do some social media stuff, help with some live shot campaigns, write some press releases, a whole bunch of stuff that really allowed me to see just the huge range of talents that exist at NASA in terms of media and newsroom capabilities. It was really exciting. And you can see on the top left corner, if we have any Mythbusters fans out there, that's Adam Savage sitting on my left. And that was during a live broadcast that NASA was hosting on the National Mall in Washington, D.C. on the 50th anniversary of the moon landing. I got to help out as a production assistant and randomly got roped into this rehearsal just for testing some lighting and sound, but it's kind of cool. I got to hang out with Adam Savage. And it just goes to show that, no 2 days at NASA are the same, and there are some incredible opportunities here. On the bottom left, that's me at my desk from last summer, and if you look closely, you'll see that there is a lot of Hubble imagery taped to my wall. And it was always an exciting part of working at Goddard last summer and driving past, the Hubble mission control and everything. I think if I could go back and tell myself last summer that I would get to go on and work for the Hubble mission after graduation, I probably would have passed out from excitement. It was a really amazing summer. I didn't want to leave, and thankfully I did not have to, because throughout my senior year of college, I was able to stay on as an audio production intern remotely for academic credit, and I got to help write and produce for the first season of NASA's Curious Universe podcast, which was an incredible experience. And you can listen to it now on SoundCloud, Apple Podcasts, all that good stuff. It was a really amazing experience, and as part of that, I actually got to help on these episodes about the Hubble mission, and so that's really where I got my deep dive on the information about Hubble, and I really fell in love with the story and the mission. And then in February, I found out about this position that had opened up with the Hubble team. I applied, and thankfully, here I am now. So it all worked out, and I got to return to Goddard remotely for now. Full-time, and now I run the NASA Hubble Instagram, Twitter, and Facebook accounts, putting out new images, new press releases, and working on just a bunch of fun media and outreach tasks related to the mission. It's been really incredible. I'm only a few months into the job, but I'm already super in love with it, and I love that I get to be back with the Goddard team full-time now. It's been really great. I think coming from a non-STEM background definitely has its pros and cons. I think working, in the newsroom last summer at Goddard and now in a communications and social media capacity, my journalism skills are really put to use every day. whether I'm editing a video or writing a tweet, little things like that where I can feel like my journalism training kicking in. But now I get to use that to tell stories that I really care about and share this amazing science and discovery with the general public, which I get a lot out of. I really enjoy it. It's been great, but also not coming from that scientific background, I definitely have to learn a lot. I'm not an expert by any means on this stuff, but I am a real enthusiast and I'm learning something new every day. I have learned so much in the last few months. I definitely have whiplash, and but it makes it really exciting and really fascinating. And I hope that the fact that, you know, I'm learning these things, I'm coming from more of the general public and communications background, that hopefully when I'm putting forth information to the public, it's in an accessible way. That's my goal with this, is to make sure that as many people as possible are aware of Hubble's discoveries and excited about them and wanting to learn more about Hubble and our place in the universe. It's been really great, and I know that there is literally no way that I would have ended up here if it hadn't been for the Georgia Space Grant taking a chance on a journalism major like me. I know that was probably a weird decision to make, or a weird application to receive, but, you know, with their support, I was able to go to Goddard and have an incredible internship that led to some really amazing opportunities that I'm really grateful for every day. So can't thank the Georgia Space Grant enough, and I'm really excited to be part of the Hubble team full time now. So I think we are going to wrap up the stream now, but I would definitely, oh, sorry, quick question. So what inspired you to even apply for an internship without a STEM background? That is a good question, for sure. So one thing about me is though I attended college in Georgia, I grew up in Florida, and I live fairly close to the Space Coast. In fact, I was able to complete a lot of my onboarding over at Kennedy Space Center for my current job, since I haven't been able to move up to Goddard just yet. And, you know, growing up watching space shuttle launches and having a lot of family that worked in the space industry, definitely, you know, NASA always felt like a pillar of my life growing up in a way. So I've always been really interested in NASA and its missions, despite the fact that I knew I didn't have a strong inclination personally to pursue science or engineering. But I always really loved storytelling and telling these stories about things that I find interesting or that I think other people find interesting. And so I remember even as a senior in high school, or like telling someone one time, like, how cool would it be to just like do media at NASA? That would be awesome. But it was very abstract. It actually wasn't until a former co-intern of mine, a classmate at Mercer University, went and interned at Goddard herself. And she was a journalism major, and she was doing strictly audio production. And I learned more about her experience, and she loved it. And I ended up applying the next year and getting in, and it all worked out. And I just fell in love with it immediately. I mean, I didn't really know 100% what to expect going into that internship, but I knew that I really cared about NASA, and I wanted to help share their stories with the public. And I think sometimes having someone who doesn't come from that STEM background go into that field and kind of have this outsider perspective sometimes can help when you're trying to frame those stories. So I just kind of went for it, and I really fell in love with it and the team there, and I knew that I had found where I wanted to be. Next question. Do you have any advice for current students who are considering applying for an internship with NASA? Ooh, yes. So one thing, I think NASA has a really strong online presence focused completely on NASA internships. So one easy thing to do is just to follow NASA internships, like on Twitter, and check out their website. There's a lot of really helpful information about the timeline of the application process and general tips like that. Keeping up with them online, figuring out what missions you're interested in, talking with your professors. NASA has great relationships with universities across the country. So odds are maybe one of your professors might know someone who works at NASA, or be able to, point you in the right direction, finding that specific aspect that you like and want to pursue more. Certainly can't hurt. So yeah, definitely just trying to track that online. from what I remember, NASA offers 3 internship seasons, basically, fall, spring, and summer. Summer is obviously the most popular and populated just because that's when most of us are off of school. But if you have the opportunity to, try doing a spring semester or a fall semester, that's definitely an option too. But the application process does happen pretty far in advance. So for instance, when I was applying for my summer internship at Goddard last year, I remember I had to put in my application quite a few months beforehand. So pretty much as soon as the year began, I was putting in that application. So I think just keeping an eye on it and anticipating it can be really helpful. Try again if you don't get it the first time. There are a lot of really cool opportunities in a lot of different fields. So even if you're not on the science or engineering track, I mean, there's a place for anyone at NASA because, NASA has a legal team. NASA needs someone to work on budgeting. So if you're a finance major, or if you're going into human resources, or if you're pre-law, anything like that, there are lots of opportunities at NASA for both internships and careers. So yeah, definitely there's a ton of online resources about this, and NASA does a great job about, advertising their upcoming internship opportunities. So yeah. What is the most surprising thing that I've learned? Man, every day. There's something where I'm like, what? Let's see if I can think of something recently. So, the star Beetlejuice, this is a recent story that Hubble put out. You might have seen it last week. Actually just started like dimming a lot last fall, and astronomers were kind of like, what? So, just for context, Beetlejuice is in the constellation Orion. It's one of the closest stars to us and one of the brightest. And so it just started dimming, and astronomers were not sure why. But using Hubble, they were able to make these interesting observations and figure out that Beetlejuice had basically ejected a lot of this like super hot matter that had cooled to form this massive cloud that was actually covering something like 3/4 of the visible surface of the star. And they're still tracking that with Hubble. So I think the fact that Hubble has been able to make such amazing observations about just stellar life cycles and things like that, it's amazing to me to think that Hubble can, make some observations that are so detailed like that. And, it's just amazing the way that scientists and astronomers are figuring out how they're going to use Hubble to get the answers to the questions that they have. They're finding really innovative ways to use the telescope every day. So that's been really cool. Another cool way that Hubble was used recently was during the lunar eclipse of January 2019. Hubble actually observed sunlight, which was filtering through Earth's atmosphere and reflecting off the moon. So that's a lot to visualize. But they used that kind of as a proxy for searching for exoplanets elsewhere. Which I think is just a really interesting and inventive way to talk about hunting exoplanets and planets that might be able to support life elsewhere. So basically, because Earth's atmosphere contains ozone and oxygen, the way that it, sunlight filtering through that atmosphere, reflecting off of the moon, and Hubble seeing what that looks like is hopefully going to serve as a method that can be used in the future when we're trying to look at the atmospheres or the stars of looking at the atmospheres of other planets to see if they might have the capacity to inhabit life. So it's just amazing all the different ways that Hubble has been used, and just the groundwork for this amazing science, both in terms of what are we going to do in the future and what are we going to do right now. Hubble has really just done so much. And so that blows my mind every day. And I'm just going to put in a shameless plug right now. If you're on Facebook or Twitter or Instagram, I would love it if you checked out NASA Hubble. That's where we put all of Hubble's new images and press releases and discoveries. And we have lots of cool products online too at nasa.gov/Hubble. While we're all at home as much as possible these days. There's lots of fun online activities that you can try, and just lots of interesting things to read and watch. So you should check that out as we're all in quarantine. All right, so I think we are going to wrap it up. But yeah, thank you all so much for tuning in, and feel free to give those Hubble accounts some love. And I hope that you learned something about the Hubble story. I really think it's really inspiring, and it's been just absolutely great